Hello everyone, today it's my pleasure to introduce the article titled Whole Microbiota Transplantation Restores Gut Homeostasis Throughout the Gastrointestinal Tract. The gut microbiota comprises distinct microbial communities across the small intestine, cecum, and colon that dynamically interact with the host to maintain intestinal homeostasis. Due to the spatial heterogeneity and homing properties of microbes along the gastrointestinal, GI, tract, fecal microbiota transplantation (FMT) primarily modulates colonic microbiota without substantially altering small intestinal bacterial communities. Here, we developed a novel whole microbiota transplantation (WMT) strategy combining small intestinal microbiota and fecal microbiota to comprehensively regulate the intestinal microbiota homeostasis. Highlights: Whole microbiota transplantation (WMT) efficiently restores the microbial homeostasis of the entire intestinal tract in germ-free (GF) mice. WMT is more effective than FMT in alleviating intestinal inflammation and reversing microbiota dysbiosis. WMT improves intestinal microbial colonization, thereby enhancing the therapeutic effect on intestinal inflammation. WMT restores gut microbiota of GF mice. In GF mice, WMT showed superior efficacy to FMT in restoring microbiota diversity and composition across the small intestine, cecum and colon, enriching beneficial taxa while suppressing potential pathogens. WMT ameliorates intestinal mucositis and reshapes microbiota dysbiosis. To assess the therapeutic potential of WMT, we induced intestinal mucositis in mice using 5-fluorouracil, 5-FU. WMT significantly restored intestinal length and lowered serum IL-1 beta and TNF-alpha, suggesting a stronger anti-inflammatory effect than FMT. The WMT group exhibited the least disruption of villus length and crypt depth. Together, these data support the enhanced therapeutic efficacy of WMT against intestinal mucositis compared to FMT. To further investigate the regulatory effects of WMT on gut microbiota, we performed 16S rRNA sequencing analysis of intestinal contents. The results showed that WMT altered gut microbiota diversity. Overall, WMT reinstates gut microbiota homeostasis and alleviates intestinal mucositis. Design of microbiota nanocapsules and their gastrointestinal robustness. We assembled microbiota nanocapsules via electrostatic layer-by-layer deposition of bioactive chitosan, positively charged, and sodium alginate, negatively charged. We first evaluated the feasibility of nanocapsules using regenerative gut microbes, including Escherichia coli Nissl 1917, ECN, gram-negative bacteria, Pediococcus, gram-positive bacteria, and Saccharomyces. The results indicated that nanocapsules significantly improved the gastrointestinal tolerance of microbiota through layer-by-layer coating. Efficacy of nano-WMT against STM infection. We then evaluated the synergistic therapeutic effect of nano-WMT in an STM-induced colitis model. Immunohistochemical revealed that all treatments mitigated inflammation and mucosal edema in the distal colon tissue, with the nano-WMT group demonstrating the greatest improvement. Immunofluorescence showed that nano-WMT most effectively reduced the fluorescence intensity of M-cherry-labeled STM in the intestinal tract, indicating decreased STM colonization. 16S rRNA sequencing showed that nano-WMT significantly improved the composition and abundance of microbiota, and markedly increased the proportions of beneficial bacteria and reduced the abundance of harmful bacteria. Summary: WMT reshapes gut microbiota homeostasis throughout GI tract in GF mice. WMT ameliorates intestinal mucositis and reverses microbiota dysbiosis. Nanocapsules enhances gut microbial colonization in GI tract. Nano-WMT shows significant therapeutic potential in mitigating inflammation and restoring gut microbial homeostasis.